students, welcome back to your maths class. In the last class, we have learned about the many concepts of chapter number 2, polynomial of class 9th. Today, we will discuss identities of this chapter. There are some basic identities in algebra. Like, before discussing these identities, I would like to tell you a very simple concept of multiplication of brackets. How to multiply two polynomials. Okay, so I will give you some simple example. Then we will come to the identities and we will also solve some important questions based on these identities. Okay, so let's start. I will take an example of bracket x plus 2 and x plus 3. So, if there is no sign in between these two brackets or in between these two polynomials, so we assume that they are multiplied to each other. Let me discuss that what are the steps to multiply these two polynomials. First of all, just take the first term of both the brackets. This is the first term and this is the first term. First we multiply x. 2x means x square. Now multiply this first term to the second term of the second bracket. It means plus, because this is plus 3x. That means it will be 3x. Now come to the second term. Multiply this second term to the first term of this second bracket. It will be 2 into x means 2x, and next second term multiply to the second term means 2 into 3, it's 6. Now solve it. It will be x square plus 3x plus 2x is equals to 5x plus 6, and this is the answer. We have learned in the last class that how to factorize a quadratic equation. But this is how we come to the solution when we multiply a two polynomial and make it a quadratic equation. It is quadratic because these both equations are linear. If one of them will be quadratic, then the answer of this multiplication will be in a cubic equation. Is that clear to all of you? Now we will moving ahead to the identities. Some very basic identities to learn about these kind of multiplication. Number 1, a plus b whole square means I can write it like a plus b into a plus b. When we solve this kind of question, a resultant value will come as a square plus 2ab plus b square. Okay, we can demonstrate it with some example. For example, a plus b and a plus b. I will take x plus 2 and x plus 2. Okay, as x plus 2 will multiply to x plus 2, it will be x square plus 2x plus again 2x, because the first term then multiplied to the second term of the second bracket, and plus 2 into 2 is 4. Okay, now we can say it will be x square plus 4x plus 4. Is that okay? This is the basic approach of multiplication. Now when we apply the formula, x is what? A, and 2 is what? B. Now x square plus 2ab means 2 into x into 2, right? Plus b square means 2 square it means x square plus 2 into 2 4, 4x plus 2 square is equals to 4. Hence, we can say that the answer is same in both the condition. And this identity is universal in all the cases when we multiply a plus b into a plus b. Similarly, there is an identity a minus b whole square. It will be equal to a square plus b square minus 2ab. Okay, the question in your examination will come into like solve this kind of solution, or there may be a coefficient with it like 3x plus y whole square or 4x minus 2 whole square. This is a simple, you can directly apply the identity in this kind of questions. But another kind of question is like, there is a question 49a square minus 20ab plus 25b square. Now what you have to do, you have to factorize this equation. And as you can see that it is a quadratic equation because the highest power in this equation is 2. So we will think about it that 49 is a square of 7. That means we can write it 7a square. Okay. Now 25 is a square of 5, means we can write it 5b square. Is it clear? Now it is minus, means minus, and 7 into 5 into 2, 7a into 5b into 2. It is it is not 20, it is 70. Okay, now this will be 7a minus 5b whole square. This is your answer. And the factor for the following equation will be 7a minus 5b and 7a minus 5b. These are the factors of this equation. Okay, this is all about the formula number 1, which was a plus b whole square or a minus b whole square. I hope this is clear to all, that what kind of questions comes into your examination and how to solve the identity. And you really don't have to remember this identity because this is a basic proof how to multiply the two brackets having the same values. Okay, now moving to the next identity, which is very important, and a multiple type of questions comes from this identity. Okay, so I will take you to the next identity. It is a square minus b square. It is equals to a plus b, a minus b. Okay, till now we have just discussed that when two brackets are multiplied having the same sign, but in this question the magnitude is same, a and b, but the sign is different. In this case it is not the whole square, it is a square minus b square, because the one term is 2ab or minus 2ab part will cut down. So a square minus b square. Now I will discuss one example related to this question. Okay, so I will give you an example related to this identity. For example, 25 upon 4 x square minus y square upon 9. As you all know that 25 is a square of 5 and 4 is a square of 2. And it is x means 5 upon 2x whole square minus y upon 3 whole square. Okay, now put the identity into it. This is your first term, we can say a square, and this is your second term, we can say b square. Now it will be 5 by 2x plus y upon 3 and 5 by 2x minus y upon 3. Okay, so these are the factors of this equation using this identity. Using this identity, you can easily factorize this polynomial. Is that clear to all? Okay, now we will discuss the third identity, which is a plus b plus c whole square. It means there are 3 terms. Till now we have discussed identity having only 2 terms. Now the another identity is having 3 terms. A plus b plus c whole square. It is again will equal to a plus b plus c. It is like a plus b plus c and a plus b plus c. One by one, when we multiply these terms, it will be equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, depending upon the sign in between these numbers, in between these variables, the sign will change in this identity also. Okay, so I will explain this this concept of sign, or you do not get confused with this. So I will take an example having a negative sign with b and c. Let's take an example. 4a minus 2b minus 3c whole square. Okay, it is having 3 terms, 4a minus 2b minus 3c whole square. Now apply the formula. 4a whole square plus 2b whole square. As it is a minus term, we can put minus 3c whole square. Okay, plus 2 into 4a into minus 2b. Is that clear? Now we have put minus sign of the b term plus 2 into minus 2b into minus 3c. Clear? Now plus 2 into minus 3c into 4a. I hope it is clear to all. Now solve this. It will be 16a square plus minus plus 4b square plus 9c square. Now it is having only one negative sign, so it will convert the term into negative. It will be 4 into 2 8 into 2 16. 16ab. Okay. Now second term, minus and minus. Now it will turn to positive. Means 2 into 2 4 into 3 12 plus 12 BC. Okay, and the last term, it is again a single negative, means it will be negative. It means 2 into 3 6 into 4 24 AC. So here it is the expansion of this question. When we multiply these terms to these terms again, we will get this answer. And by using this identity, we can easily find out that what will be the answer without actual multiplication. Okay, I hope you guys understand this. Okay, now I am moving to the next identity. This is about cube. How to solve cubes of the polynomial. When we multiply a term, a polynomial, by itself 3 times. A square is what? When we multiply a polynomial twice by itself, and cubic means cube, like a plus b whole cube, or I also will write a minus b whole cube. Okay, I will write both the identities. Now, a cube plus b cube plus 3ab a minus b, a plus b, I'm sorry. Okay, in the case of a minus b, it will be a cube minus b cube minus 3ab a minus b. Okay, this will be your identities. And 2 types of questions can be made through these identities. Like one is simple, apply the formula, like 3x plus y whole cube, it is y, 3x plus y whole cube. Second type of example can be 999 whole cube. Okay, so without actual calculation, you can find out the whole cube of 999 by writing it like 1000 minus 1 whole cube, right? And here you can apply the formula of a minus b whole cube. Your a will be 1000 and b will be 1. Your calculation will be very easy by using 1000, and here you can find out the cube of 999. And in a case of positive, like 104 whole cube. Similarly, in the case of squares also, you can find out the square of 104 by using the identity. You can write it like 100 plus 4 whole square, right? And draw the formula for this, like 100 square plus 4 square plus 2 into 100 into 4. Now, there is no number which you cannot calculate without using calculator. It's like 10,000 plus 16 plus 800. And now you can easily add the numbers. Okay, and whatever will be the answer will be the square of 104. Similarly, you can find the cube of 104 by writing it like 100 plus 4 whole cube. And here you can apply the formula of a plus b whole cube. Okay, I will solve it for you, this number. Okay, now a will be 100 and 4 will be b. Comparing these, it will be 100 cube plus 4 cube plus 3 into 100 into 4 and 100 plus 4. Clear? Now solve it. 100 cube means 1, 2, 3, 4, 5, 6 zeros plus 4 cube is what? 4 4s are 16, 4s are 64 plus 300 into 4 means 1200 into 104. Now when you add the numbers, you will get the cube of 104. This is how you have to solve this kind of questions. I hope there is no doubt in solving cubes of the numbers. It is as easy as that. It is they are universal actually, and you don't have to place your mind to anything extra, to do anything extra. You can easily solve this in the same manner. Just remember one thing: you should not overconfident while solving this question in solving the sign especially, because most of the student used to do a mistake generally solving the sign concept, the positive, negative, positive, multiplication, addition or some kind of things. Okay? But this is not expected from your kind of intelligent students. right? Okay, so moving forward, I will discuss the last identity of this chapter, which is very important, and a tricky question comes into the exam from that one identity. Okay. Okay. So the last identity which I am writing over here is x cube plus y cube plus z cube minus 3xyz. It is equals to a plus b plus c and a square. Sorry, I have to write it in a term of x, y and z. It is x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. This is the identity. Okay, and here is a very mandatory condition that the sum of these three numbers should not equals to 0. Only in that condition this identity will be applied. What will happen if the sum of these three numbers will be 0? Obviously, if the sum of these three numbers will 0, this whole right hand side term, will become to 0. Any number when multiplied to 0, it always results 0. That is why it is the mandatory condition for this only identity that the sum of these three numbers should not equals to 0 for applying this identity. Okay. Now let's assume that x is equals to 4, y is equals to 3 and z is equals to minus 7. Okay. Now try to add x plus y plus z. It will be equal to 4 plus 3 plus minus 7. It means 4 plus 3 minus 7 means 7 minus 7, which is equals to 0. Now in this condition, what will happen when we apply this formula? Now x cube plus y cube plus z cube minus 3xyz will equal to 0. Because the first term will be 0, a plus x plus y plus z will become to 0. Then RHS will be 0. Now x cube plus y cube plus z cube will equal to 3xyz. Here is the condition, and it is also a proof in your book. And it also, there are some questions comes into the exam from this only identity. It is a very important identity. And also remember the identity. Okay. So here this is all about the identities. Now in the next lecture, I will discuss some CBSE based sample questions